everyone. Next topic is Lockpicking 101-102 by Zaz.
Thanks a lot. This, if you were here last year, this is the same as the long presentation last year. So, don't really need to do it again. Hopefully Nina and Joe are going to show up at some point. I don't see them, but they have a bunch of locks and picks so people can actually play and practice with them. So it's not just listening to a lot of stuff. Plus, also, this slide deck was very kindly given to me by Tool Boston, the open organization of lockpickers, the US chapter. So I can take no credit for the visual materials. I'm just going to go through their deck. And so I'm going to leave in some of their stuff, which is important to them, such as their rules. Don't pick locks which you don't own. There's actually a good reason for that. It's not just like, we should be nice. It's because picking actually damages locks to some extent. So it's possible to pick a lock to the point where it doesn't work. So it's nice to just only do that to your own stuff and not other people's. And that's also the reason for rule number 2. If you rely on the lock, every time you pick it, you're damaging it a little bit, and eventually the proper key might not work on it. There's a few different kinds of ways to open locks. You can pick them open. You can do some sort of quick and dirty bypass. And then there's the real covert entry high-tech thing. Tool does lockpicking. Criminals do quick and dirty. And spies do the covert and high-tech stuff. So Tool teaches people how to pick locks, and they're very big. They're big in Europe. I don't know if there's a chapter here in Serbia, but there are a lot of Tool people here in Europe. For quick and dirty, they tell you about it, but don't give you the tools, and then nothing to do with the covert and high-tech stuff. But anyway, lockpicking is easy and fun. And most of what we'll talk about today are pin tumbler locks, because those are most of the locks that you see on most doors, most padlocks. This is what they look like from the outside. So you can see a kind of a wiggly slot that the key goes into. That's called the keyway. And you can just see in the front there the start of one of the pins. So here's like a graphic of what the pin tumbler lock looks like from the outside. And if you just slice away that first part of the lock, what you'd see there is the first pin stack. And so there's a bottom pin, a top pin, and a spring. And the bottom pin, often called the key pin, that's the one that changes length depending on the bitting of the key. The bitting meaning the heights that the key is cut to. The top is the driver pin, and then above that spring is what returns the lock to its original state when the key is removed. So I'm not sure I don't remember now if I have to press space to make these animations work. There we go. If you try to turn the lock plug without putting the key in, that top driver pin prevents it from moving. It blocks the rotation of that plug. If you stick a key in there, it will raise the key pin to the correct height so that now there is a gap that's aligned with the outside of the plug. That's called the shear line, and that allows the plug to rotate. So that's totally how the lock works with pin number 1. And then if we look at it from the side, we can see all of the pin stacks. Some locks have 3 or 4 pin stacks, some have 5, 6, 7, depends on the lock. So once again, the key comes in, raises all of the key pins to the shear line, and then the plug can turn and the lock can open. And all of those have to be in exactly the right place. So if that key's not correctly cut by even one bitting, so you can see here one of them is too low, and now not all of those driver pins line up at the shear line, and so the plug won't turn. Same situation if we've got one bitting too high. So the key needs to be cut correctly or the lock doesn't open. If everything was perfect, if everything was drawn like a CAD model, everything would be perfectly in alignment here. And when you turned the plug without a key in it, all of those top pins, all those driver pins would bind at the same time. Right? Bind meaning to stick. And so if you were to try and move those pin stacks, they'd all be stuck when you were applying tension to the lock. But we live in the real world where things get manufactured to a tolerance, and so that's what the holes in the plug really look like. They're not exactly perfect. Same for the pins. They have deformations and problems with it. So when you turn the plug to provide some tension on the lock, it's as likely as not, only one of the pin stacks will bind. So that means we can check the state of that pin stock with our picks. So here, viewed from the front of the lock, if this pin is binding, and now we push up that stack, then we are able to detect the point at which we encounter the shear line. So watching that again, as that stack comes up, you can see we get a little movement out of the plug when we hit the shear line. And then after that point, we call that the driver pin being set. So after that happens, it's going to be locked in place. And now the bottom pin can just fold down freely, and we'll be able to see that jiggling up and down, or you can shake the lock and jiggle it, push it with your tool, whatever. And so to do that for a complete lock, we just do that process over and over again. So the piece that just came in at the bottom there, that's our tension tool. That's what we're using to apply a torque to the lock. And now we use our pick to test some pins. These ones are moving more or less easily, but this one has got some tension on it because it's binding, and then we can click it into place. Now a different pin is binding. And so this process just repeats, finding the binding pin until eventually the lock will open. I'll let the animation play. And this animation's been developed as though we're not keeping track of which one's binding. So sometimes it'll go and test some of the ones that have already been set. And hopefully, yes, let's do the last one quickly. And then the lock turns. So that's basically what we want to do to pick a pin tumbler lock. One of the things we have to watch out for is overlifting. So that's where we're tensioned our lock and we're pushing up the pin stacks, and it's not that difficult to quickly whip one of these up above, so that the key pin ends up above the shear line. I think it'll be on the last one here in this animation. And so now there's nothing that we can do to open this lock, even after we test all the other ones. So the right thing to do, like you just saw, is if you're picking a lock for a while and you think you might have overlifted a pin and it's not going to open, just release some tension a little bit, let those set pins click back down again and start again. So the lockpick that we just saw used in those example is just a hook pick, so it's designed to actuate one pin stack at a time. But there are lots of other types of picks. So for example, this is a rake, and what you're doing with raking is basically you're playing the odds. You're doing kind of a probabilistic approach, and you're wiggling around all these pins at once and hoping that they set and then the lock opens. So you can, when you're lucky, rake open a lock really, really fast. But raking can be not so effective if the bidding of neighboring pins is very different, right? If you need to move one pin some small amount and the other one a large amount right next to it, the rake's not necessarily going to be able to make that happen. The half diamond, so here we've got hook, half diamond, and rake on the screen, and the one in the middle is the half diamond. The half diamond is pretty cool. It's like if I only have one pick on me, it would pretty much be a half diamond because you can lift pins with it. You can also sort of rake with it by shoveling back and forth, and that's causing pins to flip up and down. And you can count pins using the flat underside. So you flip the pick over, put it all the way in, lift all the pins up, and then as you pull this back, you'll hear or feel, or both, click, 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 as those pins drop down, and that lets you know how many pins you're dealing with in the lock. The tension tool, sometimes these guys call it the turning tool. It's just basically an L-shaped piece of metal. And usually you won't want to pull on the tension tool by using your thumb. Instead, push it with your finger from the other side. It's a better technique. And the further out you can push it, the more leverage you have, and that gives you more control. You're not necessarily because you want to push that cylinder around really, really hard, but you just want to be able to apply more or less force, and that's easier with more leverage. And so a good rule of thumb, or rule of finger if you want, is to sort of look at the color of your finger when you're pushing on it. So here you can see the finger is still pink, but if you're pushing too hard, it's got white at the end of the finger. You're probably putting too much pressure on the lock, because you have to make the set pin move, right? So the harder you bind that pin, the more difficult it's going to be to lift it with your pick. And so putting too much tension on the lock is going to work against you. You can usually use these tools that turn at the edge of the plug, so sliding in the bottom there, and your turning tools look like this. Sometimes they've got a bit at each end. Sometimes they're folded over or folded and twisted. The one on the left is folded and twisted. The one all the way to the right is just folded. A lot of this is just personal preference, what you end up liking, so this is a good reason to mess around, have some fun, and see what you like. They come in different widths, because when you've got a tension tool jammed in the keyway, that takes up some space, and that space that you can't use to put your pick in. So sometimes you can get these slimmer profile ones that take up less space in the keyway. That's showing that's the room you've got to move in. And then you can also, there's a slide later on, use one that turns from the center of the plug instead if you need that bottom space in the keyway. Be careful here, you don't want to jam it into the bottom of the keyway, because then you're causing friction that's actually preventing the cylinder from turning. Here's an example of the flat turning tool on the right that you can turn from the center of the plug. Occasionally useful, because it gives you more space to work with. But you're still, blocking some movement of your pick. If your pick has is itself wide, it might run into the bottom of the tension tool there. So it's not the kind of magic thing that's just like, wow, why don't we just always use that? Because it does still block the keyway to some extent. Not all locks open in the same direction. So it's good to sort of have an idea of which way to be turning it. So it's gonna unlock it. Padlocks are often in the clockwise direction. Door locks are often the other way, except for Schlags, which are clockwise again. Deadbolts usually go both ways. Depending on which handedness the door is. So if the latch is on the right of the door, then the deadbolt is going to retract counterclockwise most likely, and then clockwise if it's on the left-hand side of the doorway. I will just skip through this stuff because this is for the Tool Lockpick Village, but Tool sells a range of practice locks, and they have different numbers of pins and different difficulties. They have some anti-picking things, which I'll get to later. They tell you which is the front and the back. And on those practice locks, either directions will work. So when you're getting started, and again, hopefully we'll have some stuff set up outside after this, practice lifting a pin with the pick, practice tensioning the lock and getting pins to bind, practice finding the binding pin, and practice different types of lifting. Sometimes you want to lift up directly, sometimes you can sort of rock it and you can use the bottom of the keyways for a bit of extra leverage. and just relax and tell people when you got the lock open. I'm just going to move past questions, but you can shout out questions if you have them. Interrupt, I don't mind. Another type of lock that you'll see a lot of is wafer locks. So wafer locks work basically the same as pin tumbler locks, except instead of pins, the pieces that interrupt the lock are stamped pieces of metal. So flat pieces of metal that we call wafers. So that's what one that's got its case removed looks like, and you can see all of those flat metal wafers sticking up out of the plug, and they can move up and down. So if you look at it from the front, you see the front of the lock, and then you can see the red piece there is one of the wafers. If you slice away that front of the lock, you can see what a wafer looks like. It's kind of an oval. It's got a rectangular piece at each end, which is what interrupts the rotation of the keyway. And then the piece in the middle, where that rectangle is cut out, is like the length, in the case of the pin tumbler lock, like the length of the key pin. So that determines, when you put the key in, how much this gets pushed up, such that it ends up in a place where the two shear lines are aligned and the lock can rotate. So this is just like an easy and cheap way to make locks. You don't need 2 pins per stack. You don't need springs. You can make these locks very, very inexpensively. And so that's why you find them on filing cabinets, on electrical panels, stuff that is not necessarily high security. And these can be picked generally pretty easily. You can use your regular lock picks on them, and then you can also buy specific lock picks for picking wafer locks, and especially wafer jigglers. You can buy a set from places that sell lock picking tools, and they're just like a set of a few different keys that'll fit most wafer locks, and you just put them in and jiggle them around, and usually these things will open very, very quickly. Combo locks are things which you find a lot of the time around the place, especially the master combination lock, which is infamous for being very, very common. School lockers and stuff like that, and also really easy to bypass in a couple of different ways. So if you put one of these on your locker, you're basically just telling people not to open it, because if they try, they will open it really easily. It was fun last year when I gave the short version of this at the start of the conference. Someone came along with one of these locks that they'd forgotten the combination for, so we got to practice all of these techniques for opening it. The easiest way to open it is with a padlock shim. So this is a very slim piece of metal that you slide down the hasp, the shackle of the lock, and it just pushes the latch out of the way. It's just kind of like using a credit card to open a door. You can make these really easily out of a can. So get one of those yellow beer cans that are everywhere here, and cut a piece of aluminum off the can, fold it over, and then you've got yourself, a nice disposable shim. This won't work a lot of times because aluminum is soft, but it'll work long enough to open one lock. Bend it around the body of a ballpoint pen, and then you've got a free padlock shim. And then you just slide that down. This works on on most of these types of padlocks. On the master lock, the latch is on the left. The one we found last year and we opened with a shim, the latch was on the other side. So you might have to try both sides of the padlock to get this to work. And then it'll just pop right open. So these are super easy. And this is opening some truck lock with a Guinness can, padlock shim, kaboom. Sometimes you need 2 shims. Some of these padlocks have a latch on both sides. Lots of padlocks that are better quality and more expensive, you can't shim. They have this double ball bearing mechanism. So you can see in this diagram, the 2 ball bearings are inside the cutaways in the shackle. The shackle can't come out. Then that big chunk of metal in the middle, when the key rotates, that rotates and allows the ball bearings to slide inwards, and the thing opens. But when the lock is locked, when the key is not in there and turned, that big piece of metal is blocking the ball bearings. They can't move. So there's no way to push them out of the way with a shim. So you can't shim this type of lock. This slide, the one on the right is the one that you'll typically see on a double ball padlock. And then there's you can actually buy a lot of cutaway versions of all these locks really cheaply now. China, for whatever reason, is fully got into the locksmith teaching tools game, and so on Amazon there are all these acrylic-bodied, see-through, transparent locks, and you can get a full set, for $15 or $20, including disc detainer with double ball bearing, and various just pin tumbler padlocks, and you can see what's going on. They're really, really handy and fun for practicing lockpicking because you can get the visual feedback. This is kind of fun, the way to decode the combination for these master locks. Many types of mechanical combination lock and bad safe locks are subject to attacks by feeling what the lock does as you move the combination dials around. You could get that kind of tactile feedback. And the usual way you do this is you put some tension on the shackle, and sometimes I've seen some sites advocate putting a string around it, and that way you can slip your hand in that string and just really have a lot of leverage on that while you manipulate the dial. But you put some tension on it, and then you rotate the lock. First thing, by the way, you have to do is to spin this lock clockwise about 3 times so that you have reset the lock. But then you're going to rotate the dial and feel where it seems to stick when you've got some tension on the shackle. And it'll stick, for every stick position, it'll actually stick a little bit either side of the true position. So you sort of feel where it starts to stick, and then you go from the other side and you feel where it starts to stick. And get an idea of either side of the sticking point, and then write down what's in the middle of the 2 sides of that sticking point. So in this case, if we've got it starting to stick at 4 and starting to stick at 6, then our sticking point is 5. But be aware with this type of lock that in a bunch of cases, the sticking point is going to be at a fractional point. It's going to be at the half point. Either side is going to be a number and a half, and the middle is also going to be a half. And then you're going to write down all of the places where it sticks. For this type of master lock, there should be 12 sticking points. And what we're looking for is the odd one out. English idiom, the black sheep of the family. So we're looking for a number that's a whole number. We're not going to worry about the fractional numbers, and that doesn't have the same last digit as the other whole numbers that we found. So let me go back here. If we look at this one, we can see we've got a lot of fractional ones on either side, and then in the middle, all the ones have a last digit of 5. So there isn't an odd one out here. So that means we fucked it up somewhere, and we didn't get exactly the right sticking point. So we go back, look at our fractional sticking points. Are we really sure that they're all in the right place? So no, we got this one wrong. It's really 23, and that's the one we're looking for. That's the odd one out because it's not a fraction. It doesn't have the same last digit as the other whole numbers. That's the one we want. And this gives us what we can call a magic number. The magic number is the modulo 4 divisor of this number. So you divide the number by 4, and the remainder is the magic number. So in this case, it's a 3. And now that's going to be the last number of the 3-digit, 3-number combination, right? So to open these locks, you set them to 3 numbers. 23 is our last one, and 3 is our magic number. And so now we can come up with 20 possibilities for the first and the second number based on this. So for the first number, we start with the magic number and then add 4 repeatedly to it. And that's our 10 possibilities. We know the first one's 3, 7, 11, 15, so on up to 39. And then for the second number, if our magic number is a 0 or a 1, add 2 to it. Or if it's a 2 or a 3, subtract 2 from it, and then add 4 in sequence. And so what we have is 100 things to try, because we know the third number. And so, this little bit of arithmetic followed by just trying these combinations, you'll probably decode the combination in maybe 15 minutes, something like that. So that's kind of fun. And of course, once you have the combination, it always works. Unlike shimming it open, then if you lock it, you've got to shim it again. This time you've got the combination, and so you can secretly open this lock whenever you want to. And this type of technique works for a lot of other types of locks too. Not the same one with the magic number and all that kind of stuff. That's unique to the master combo lock. But putting tension on the shackle and feeling for where different wheels bind and where the shackle moves a little bit, that's just a great technique in general for decoding combination locks. So I said before, at some point we'd get to pick resistance. So this is back to pin tumbler locks again. So everyone knows that these lockpicking methods work on pin tumbler locks. So lock manufacturers have made ways to, or developed ways to try and make it harder to pick things. So the first kind of line of defense is to choose the right keyway. A keyway that's got a lot of open space on both sides, has a lot of room for picks to move in. That makes life easy. We can make things a little bit more difficult by making the keyway a little more funky shaped, or making it really, really thin and curvy. We can make it really hard. You can see there's not a lot of room to move a pick around in. And then something like this, that really, really makes it tough to put a pick in there and move it up and down. So, it sort of depends on the security level of the lock. But let's say, given a normal, fairly simple keyway, we can also make the pins resistant to picking. So this is one of the common pick-resistant pins. It's called a spool pin because it looks like a spool of thread, and the spool pin allows the lock to turn even when, a little bit, even when the driver pin is not at the shear line. So we're not able to detect on that pin stack if we're in the right place or not, because the lock's going to turn anyway. Let me see. Yeah. So even when we push that pin up, we might think we're in the right place, but it's binding at a place where the lock won't turn. So if you're trying to pick a lock with a spool pin in it, spool pins are a little bit more expensive to make, so often a lock will add security by just adding one spool pin. They won't be in all the pin stacks. So if we think that there's a spool pin in a lock, we can still try to pick it, because we can sort of mark on the keyway where the 0 point is, and we can see the lock move both sides of the spool pin when it's in the correct binding, the setting place, and when it's not. And so we can ease off some of the tension as we lift that spool pin. This animation here is assuming that it's the last pin that we need to pick, that we have the other one set, and we can sort of back off a little. But it's easier said than done, because the other pins are going to drop down when we release the tension. So you have to sort of develop an idea of where you think that spool pin is. But spool pin locks are still definitely pickable. There are other kinds of pick-resistant pins that we see. The mushroom pin, which is similar to a spool. The serrated pin, I have a lot of trouble with these. I found a lock the other day on the road and had a padlock, and I'm like, oh cool, let's practice picking. And it turned out to be some high security padlock where every single pin was a serrated pin. And so these pins just bind constantly. Everywhere they are, they jam in, and once they're jammed, you can't lift them. It's very difficult to tell where the real line is. And actually, so I picked up this padlock. It was open. I locked it, and then I haven't been able to pick it open yet. I've spent like a couple of hours on this lock and haven't been able to get it back open again because it's all serrated pins. Not that I'm the greatest lock picker, but Then there's ASSA has this sneaky pin, which it's kind of a double spool. And then these are sort of like vendor proprietary pins. There's a double mushroom as well. And yeah, these really make picking a lot more difficult. You can still pick them, but you have to be very skilled or be very lucky. Like you can maybe rake them open and then just happen to get it the right way once, and then spend an hour trying to do it a second time. Another kind of interesting attack that became super popular, I don't know, 15 years ago or something like that, bump attacks. You might have heard of bump keys. So the bump key is basically a special kind of key that's been cut down all the way on all of the bitting, and then had its shoulder a little bit shaved off. And then you need a little bit of skill to use them, but a lot of locks that otherwise are pretty high security are vulnerable to bumping, and it's related to physics. It's related to physics like you'd see on a billiards table, pool table. So on a pool table, when you hit two balls that are touching each other, sorry, I messed up the animation here. Here we go. The 3-ball there in that animation doesn't move because all of the force is transferred through it to the next ball, and it's the one that moves. And this technique is used in these pick snapping guns that you might have seen. Sometimes these show up in the movies. Some spy movie or something. The dude will just stick this gun in the lock and it'll open. And how that works is it whacks all of the pins at once with that little snapper thing. And just like the pool balls, that impulse force to the bottom pins is transferred to the driver pins, and they all very briefly flung up above the shear line. And so if you turn that plug at just the right moment, when all the driver pins are up above the shear, then the lock will open. It's a close-up of that mechanism. So bumping works the same way. You're using the ridges on that deep cut key to slap those pins as you, in this case, jam the bump key in, or you can also do it the other way and pull have the key only go a little bit in. So this is one where you have the shoulder of the key filed down a little bit so that the key goes in a little further than it ordinarily would. And so what's not shown in that animation is you're not just pushing that key in by hand. You have a little hammer and you tap it, and that knocks everything up, and you tap and turn it in just the right timing, and the lock will open. And even relatively high security locks like Medicos and so on have been susceptible to bumping attacks. Here's an example, sort of going back to the beginning of don't do this to locks you don't own. So here's an example of a lock that's been bumped to destruction. You can see the cracks and dents there where people have just been whacking into this lock. There are some countermeasures to stop bumping from being effective. So one way is to have a driver pin that has a little shelf on it and sits above the key pin there, so that when they're bumped, there's not an animation for that one, that final pin will jump up, but it won't transfer the force fully to that last pin, and it won't lift that last pin. So there'll be one pin stopping the lock from opening still. And then you can also get these anti-bump driver pins. So this is a pin that has a different spring and different mass, and so it's not going to move the same way as all the other pins do when they get bumped. Here's a picture of that. And you can see online, these bump resistant cylinders and conversion kits to make locks bump resistant. This is just a bunch of slides on resources where to find locksmiths and tools, which I'll just skip through because I'm sure they have no relevance to Serbia. You guys will have to find where to get tools and supplies from. The thing with picking is once you're done, the lock is open, but if you lock it again, you have to start all over again, right? And maybe you just got lucky and raked it open and it's a really hard lock to pick, and maybe it could take a really long time to open it again. So it doesn't give you any kind of future access to the lock. The exception, I don't have any slides on it, are the tubular lock picks. So you know the tubular locks that are often on bike locks, vending machines. In Will's talk yesterday on freaking elevators, most of the elevator panels that he showed had tubular locks on them. You can get picks for those too, and they're basically an impressioning tool. They have a bunch of little pins that have like a rubber band putting some tension on them, and you manipulate them into the lock. And once you get it open, the position of those pins is set, and you can use that. And if you don't reset your tubular pick, you can use that to open that lock over and over again. So you've basically got an impression of the lock. And you can do impressioning with a blank key for normal pin tumbler locks too, and end up with a working key. So that's why at the end you've got a key. So what you do is you start off with an uncut blank and push that in there so that all of the pin stacks are raised to the maximum point. And then you turn, the lock's not going to open, right? All those key pins are above the shear line. But if you turn it real hard, now you're going to bind at least one of those key pins, hopefully just one, and then wiggle the key, and you're going to cause some rubbing on the top of your key. And then you take your blank out and you look at where the rub marks are. So right here we've got two spots where they rubbed, and we filed them down a little bit. So you get a little tiny file down the key where the marks are, and then keep doing it. Still binding at one point, still getting a rubbing. Then look for our marks, file it down a little bit more, and keep going. And at the point when one of the pin stacks stops binding, you'll get a new mark from somewhere else. So here we've got a mark from this stack, but not from stack 4. And then also a new one here. So, we file down the new marks. We're done at the ones that don't have marks. This can take a while. Let's see, can I see the mark? What do you guys think? Starting from the shoulder, 1, 2, 3, 4, or 5? I think, yeah, 2, that little tiny mark there. So, this is definitely a skill. It takes some practice, and it's a lot easier to do, like with these guys in competition, if you can put the lock in a vise, and then you've really got some ability to wiggle this key and make marks on it, but you can make a working key doing it that way. And Tool runs competitions doing this stuff. I think there's a video here. Will it play? No. All right. Well, anyway, spoiler alert. He does it a few times and files down the key, and the key works. A lot of systems in real facilities, like buildings and stuff like that, are mastered. So if you've ever wondered how master keying works, the next bit will explain it. Mastering, the point of doing it is so that you can give everyone keys to their own office, but the cleaning staff can get into all of them, right? Or the building manager can get into all of them, or different areas can have different cleaning staff that can get into all the rooms. So you need a single lock that will be opened by several different keys. And the way that works is we introduce a new type of pin. So we have key pins, we have driver pins, and now we have master pins, which are usually these little thin slice pins. So we can see here that a key that lifts the some of the key pins to the right height and some of the key plus master pins to the right height will open the lock. But for a given stack, we can open this unmastered one here on the right with a single key that's cut to an 8-bitting depth. But if we if we convert that 8 to a 6 and a 2 with a 2 master, we can now open that with a key that's cut to a depth of 8, like the original key, or one that's cut to a depth of 6 at that position. The thing is with mastering is that obviously it makes the lock a little bit less secure because more types of keys can open them. But it turns out it actually makes the system a lot less secure because we can figure out, if we have a working key to a lock, we can figure out what the mastering depth is, the master bitting depth. And so we can actually, this is a fun thing to do if you're bored at work and you work in such a facility, is you can figure out what the master key is for your own office by getting blanks and then filing them down progressively to figure out what exactly the master bitting depth is. So I'll run through that. So if we know that we have a 48426 that opens it, so now if we get another one cut, and you can go to a locksmith and you, at least in the US, you ask for a key cut to code. So if you know what type of key it is and you know the bitting depths, you just tell them that code, 46426. Like you say, all right, I want a Schlage C cut to 46426, and they'll do it for you, as long as it's not a restricted key, a restricted blank key. And oftentimes they'll do it for you anyway. Depends on the locksmith. Or, of course, you can buy some blanks online. You can do it yourself. So we know our office key is a 46426, but we're going to cut ourselves a 40426. And then we try it. It doesn't work. We cut it down a little bit. We try it. It doesn't work. Cut it down a little bit more in the 2 position. Still doesn't work. Eventually, we cut it down, and it opens. So I guess our original key was a 48426. But now we know that 46426 also opens the lock, and so we know there's a height 2 master pin in the second position in that lock. And we can repeat that for all the pin stacks in our key, and then we've got a master key to the building, and we can go and break into everyone else's office. Cool. And that was originally published 2003 by Matt Blaze, master keyed lock vulnerability. And this absolutely works on any master keyed pin tumbler system. As long as you do it right and you file down, get a vernier caliper or a micrometer and you file down to the correct differences in bitting of your key, which for a Schlage is, I think, 15 thousandths of an inch is between adjacent numbers of bitting depth. But you can look it up for whatever type of lock that you have. Here is just sort of an overview of different types of picks. If you go to one of these corporate conferences which have sponsors and vendors, unlike BalCCon, which is more community oriented, but many of these conferences will have lockpick vendors and stuff in the vendor village, and they'll sell these sets, and they'll have like 50 different types of lockpicks, and you're like, what the hell are all these good for? I mostly just use a half diamond. Well, anyway, here's what they're good for, and you can also, of course, get this stuff online. And you'll get these beginner sets, advanced sets, like master sets. They've got tons of lockpicks, and it's like, what do I use these all for? And they also might be made out of different stuff too. They may usually made out of spring steel, which rusts. Probably about as common, stainless. And then you can pay a lot of money for your titanium picks or whatever if you want. But regular stainless is usually the way to go. And different thicknesses too, but if you're like really into this stuff, you might care. And then you will often see stuff described as standard profile or Euro profile, which usually refers to the sort of shape of the shoulder of the pick there. The The one place I care about that is I always get a few Euro tension tools because they narrow down at the point where they go into the keyway, and so often, especially with cheap padlocks, there's often a very narrow space at the base of the keyway, and the Euro profile tension tools will fit in there nicely, whereas the normal ones won't. So here's lots of different types of picks. We saw these already in all the demo animations. These are the hooks, and you can get all kinds of different shapes of hooks. I would say mostly your kit should probably include a short hook and a medium hook. The difference that you care about in hook length is when you're reaching past pins that are not binding and you want to lift a pin that's just binding. Sometimes you want a longer hook and sometimes you don't. It depends on the lock. So, you know, typical and awesome the descriptions there of the short hook and the gonzo hook. I've never purchased a gonzo hook. I've never even seen them in the place I buy picks from, but a long hook is useful. You have these also reach tools, you know, for getting past when you're dealing with locks with a lot of pin stacks. Then your diamonds. You can also get different shapes. Mostly a standard sort of starting kit will just have one size of diamond, and that's usually enough. And there seems to be no real point to having a diamond on both sides, because then you can't use it to count pin stacks. And you can get these ones that are sort of offset. So again, to help you reach past and into the back of a lock when you're getting past some pins that are in the way in the front. Then these ball profile, which is, you know, sort of like a, in my opinion, sort of like a diamond, but maybe less useful. I don't know. This says the snowman can be useful, but I don't really know when. I've never really found a good use case for those. That's just, you know, when I get a kit that's got these in them, I usually just like either never use them or just take them out to save space. But maybe some people find them useful. These raking tools, many different types of rakes. So you'll normally get like a C rake in any beginner kit, and you'll do your raking action. I don't personally tend to have a lot of success with these standard rakes, but I don't know. I'll show another one that I like better in a sec. One thing to look for, like you can see this one, if a lot of metal has been cut out of the pick itself, eventually you might be left with a weakness that can snap off inside the lock, and then that kind of really sucks, because now you've got this piece of metal jammed in the lock that's very, very difficult to retrieve. And if you're, you know, violating the rules and picking a lock you don't own, then the owner is going to find that their key doesn't work anymore, and because there's a piece of metal stuck in the lock, and they're going to know that someone's been messing around with their lock. These are the types of like lifter rakes that I really like, and so the difference here is, you know, you're normally just wiggling this in and out more or less, maybe at a different angle with a rake, but with a lifting tool, you're sort of like lifting all the pins at the same time as you do it. And so this L rake are the ones that I really like, or at least I feel like I have more success. You know, not being scientific about this or anything, I just use it for a while and see what happens. But I feel like I have more success with an L rake than with a standard C rake. Kits don't always come with an L rake in them, but I always buy one separately and put it into a kit, because I keep a kit in every backpack, so I've always got a set with me, and you know, individual picks are actually really cheap, so you can just get a basic set and then add one or two of your favorite individual picks to them. These I've never seen in person, the King and the Queen, so I have nothing to say about them. But one of these ones that people really like in the lock sport world are the so-called Bogota rakes, which I guess were developed by a Colombian guy, Raimundo. And so these things are sort of like in between a rake and a lifter. And they started off as a kind of jiggler tools. And you can get various types of jigglers too from vendors of lockpicks. And what you basically do with them, it's sort of in between what you do with the rake and with the lifter. You sort of put these things in there and you just wiggle them around. And they're usually sold in sets of jiggler tools, and so you'll try one and wiggle it a bit, and if it doesn't work, you'll try another one. Again, you're sort of playing the odds. You're doing the probability of, like, if I just like manipulate these pins enough, eventually it'll open. But some people really swear by them, and if you like lock yourself out and get a locksmith, and the locksmith doesn't drill your lock right away and replace it, it's very, very common that the locksmith will come with some jiggler tools, and that's kind of the first thing they'll do is try jigglers on your house. You've got some low security 5-pin Schlag on your, or a quick set on your house. The locksmith is most likely going to come along with a jiggler tool and just try that for a while before drilling out your lock. So these Bogota rakes, sort of owe something to the jigglers too, and they look basically like this. And I actually don't have any of these. I think maybe a couple of my kits came with one in there, but I haven't used them a lot. But the Locksport people really like them, so I don't know. Try them out, see what you think. How are we doing for time? 5 minutes. All right. Let me see what's here. There's a whole bunch of stuff here on looking for tool marks on locks. I guess I'll do it just for fun, but I'll take time for questions too, or you can talk to me afterwards as well. So this is just kind of interesting. This is not something, unless you work in law enforcement or whatever, you probably would never see any of this stuff. But to me, it's just interesting that you can see, if you really look at pins, whether or not they've been picked and how. So when you get a pin from the manufacturer, some little high-speed lathe machine has made those picks and has left tool marks on it, most likely concentric circles like that. And so you can see how it was when it was first made, and then as that's used to be in the lock, legitimately unlocked, you've got a key rubbing across its face twice every time the lock gets opened, at least twice, because it goes in and goes out. And so you can sort of see how these tool marks wear away as the key is legitimately used in the lock. Now, similarly, the plug is scraping against those spring-loaded driver pins every time it turns, so you can see what happens to a plug after it's been used a lot of times. And these are all sort of predictable marks from normal use. But picks go to places that keys don't. The key is mostly touching the bottom of the pin every time, but a pick can reach around and scrape the side of it. So we can see interesting marks on here that maybe aren't subject to normal wear and tear. So if you look just there, there's a mark on there that would never be caused by a regular key operation of the lock. So here are some examples of the kinds of marks. And again, this is what I was saying. Every time you pick your lock, you're doing a little bit of damage. And you can see when you're picking, often little tiny flakes of brass come out, because brass is a soft metal. It's easily scratched by the pick. So then you got marks all the way across the face from a rake, mixed picking there, and this is why you don't want to practice on other people's locks and upset them, because eventually you're really going to wear down the pin, and sooner or later it might not open. Especially if the legitimate key is multiple generations from the original key, and so every time it's been cut as a copy, a little bit more error is introduced, and probably many of us have experienced the case where we've had a key that previously worked, now it's sticky and doesn't quite work right, and you got to wiggle it when you get in there, because it was never really perfect to begin with, and things have worn down a little bit. The snapper guns, which are, this is just a total bypass tool. There's no skill in it, so the lock sport people don't like them. But they're whacking the hell out of the pins, and so you can see these snap gun marks on the pins. And then, especially when you're beginning, sometimes you don't know where the last pins are, and sometimes you'll really jam the pick in and scrape the back, so you can find tool marks on the back of the keyway. And also, like I said, right when we're talking about tension tools, if someone's putting too much downward pressure, they can scrape the bottom of the keyway, and you can see that too. And then also, if people are trying to force the lock, of course, you'll see some tool marks like that. The bump keys, these are alleged to be bump key marks. I'm not sure if I guess if you were a police forensics guy, you might be able to spot these and say, yeah, that was definitely a bump key, maybe. Let's see what's left. All right. I'll play this stuff anyway. Okay. These are some of the resources for learning more. So. Practical lockpicking. Deviant Ollam is the guy who did most of these slides, I think. Certainly all the key animations Deviant did. Deviant also, Will thanked him yesterday in his elevator freaking talk. He gave him a lot of head start stuff on the elevator freaking, so Deviant's cool. And his book has a lot of this stuff in it. Mark Weber Tobias is sort of one of the guys who's written the most books on locks and safes and stuff like that. There's a whole bunch of his stuff out there, and he's also given a number of long talks at hacker conferences, so you can look up his stuff if you want to see some really in-depth things. And then, of course, the tool websites. There's a guy actually, in terms of videos, there's this guy, the Lockpicking Lawyer, and he does some really good YouTube videos where he'll take some sort of lock, whatever it is, per video, and do a careful deep dive into how it works and how to pick it and stuff like that. I like his videos a lot. The tool websites and Deviant's site is deviating.net. Blah blah blah. Yeah, legal questions are something maybe you should look into. Is this really varies by country and by state, whether or not lockpicks are considered burglary tools. So in the United States, I think it varies by state, but usually they're not a burglar's tool unless you're using them in a burglary. So funny story, just this week, some penetration testers for a company that friends of mine work for, they were doing an assessment on a courthouse, and their like scope of work said they needed to figure out if there's any way that someone could get the court records. But the courthouse thought that they meant just electronically, right? Just like hacking over the internet. But these guys thought it was a full scope of work. So they broke into the courthouse, and then they set off an alarm or whatever and were caught. And so then they were put in prison and charged with burglary and possession of burglary tools, presumably their lockpicks and stuff. And so, we don't know yet if they'll keep pressing charges, because they really were, hired to do it. But the people who hired them didn't realize when they said, find any way to get the records, that they were going to actually physically break into the courthouse. So if you do penetration testing work, make sure you've got all your scope of work fully signed off on. And check your local laws, because some places, in Australia, for example, people often ask me, have I ever been hassled for carrying lockpicks when I fly? Because I always carry them. And the answer is twice, and those times were both in Australia. I was hassled at the airport. And in Australia, picks are considered burglar's tools if you're not a locksmith. But what does it mean to be a locksmith? So I said to the guy at the airport the second time, I'm like, well, yes. When someone asks you if you're a locksmith, you say yes, right? I mean, that's the right answer. So I said yes, and he said, can you prove it? And I said, how do you want me to prove it? There's no locksmith license. And he's like, well, do you have a business card? And I said, no, but, and so he made me check them. But then I went home and I had some business cards made that said locksmith on them. So I haven't had to try those yet, but I think it'll work. But check your local laws. Yeah, all right. I think that's enough. I think think the time's up. Yeah. Any questions? Yeah.
It's possible when there is a key inside of the cylinder on the other side. How to solve that? And you can even with the regular key, you cannot unlock it if there is a key on the other side. Can you push it out and then?
Yeah, I mean, most pin tumbler locks they are not accessible from both sides. Oh, so the question was, what if there's a key stuck in the lock from the other side and you're trying to open it? Can you push it out? In the case of pin tumbler locks, it's not common to be able to put a key in from both sides because the key would have to be symmetrical. In order for the same key to work on both sides. But there are these ones that you get in China. I think there's a slide here that's got a picture of one. Let me see if I can quickly find it, where they'll have two sets of pins, and you can unlock it from one side or the other. In that case, you can't reach from one to the other. You can't push that key out. But if the key is in place, the lock, it's not going to stop the lock from turning. The exception is the old school warded keys, the sort of classic icon of a key, where it's got like big handle and a thing and these kind of wards on one side. It was common for them to be able to be used in both sides, and one way that people were warned, if you have that kind of key on your hotel room door or whatever and you're asleep, don't leave the key in the lock because someone can push it out and put some paper under the door and catch it and then like bring it under the door. But no one uses those keys anymore. Maybe in Africa or something, I don't know. Let me see if I can find the picture of this Chinese style lock. Oh, that's right, it was in the impressioning section. So this is the one that I'm talking about, where you have two separate cylinders, and the latch in the middle, when the cylinder rotates, that piece of metal in the middle is what actuates the latch that opens the door. And so those cylinders are the same on both sides, with the exception it's a whole talk in itself, and this guy gave it at DEF CON China this year, so you'll be able to look up the video if you're interested. This guy's name's Lucas. He did a whole presentation on Chinese locks, and they do a lot of interesting things. Like there's a kind that they make where they're called construction locks. So these are a lock you'd put on your house when the construction person is working on it, and when they leave, you sort of reset you use your key to reset it so that they can't get in anymore. And so they're these kind of, but you don't have to change the lock. So they're designed to be installed. The construction guy uses it, and then when you use your key on it, it resets the lock just to your key. And so there's a lot of these really interesting Chinese locks. And so if you're interested, you should watch that presentation. Yeah.
How familiar are the locks here in Serbia? Like, are you seeing loads? New ones or like no new ones? It's all the same.
Oh, I know nothing about locks in Serbia. Yeah, well, I haven't looked at the ones actually in this building, and then of course it's the electronic locks in the hotel. So yeah, I haven't really looked. Anyway, Kirill should come and get set up here. I can answer questions and talk about locks afterwards.